morning, everybody. We are going to work on Chapter 8, Practice Test Number 2, and we are ready for Problem 1E. So it's the back of the front page of Practice Test Number 2. So we're going to write the equation of a couple of hyperbolas. Remember that your test is only going to have one of these, but we have two just so we get a little extra practice. So our hyperbola equations are going to look like this. And let's see what we've got in E to help us figure out what goes where. So we've got a center at 2, 4. That's our center now. That's our center. It opens horizontally, so that means my vertices are out here. I don't know where exactly, but it opens like this, so it opens sideways. Now, what does that tell us? If it opens sideways, then x must come first in our hyperbola equation. Now, as soon as I figure that out, that x comes first, then I can plug in my center. So x minus 2, y minus 4. So the tops are done. All I need to do now is figure out what these two numbers are. So let's see what it tells me. It tells me the transverse axis. Now that's this one. Vertex to vertex. The transverse axis is 10. So that means I'm going forward 5 and backward 5, which means under x must be a 25. Because the square root of that number tells me how far forward and back to go to put my vertices. The conjugate axis, which would be this one right here, is 6. So I'm going up 3 and down 3, which means that number is a 9, and we're done. Easy. All right. Number F, letter F. Let's see, what do we know this time? The transverse axis has endpoints at 2, 3, and 2, negative 5. Now stop, guys. The transverse axis. So this is my transverse axis, which means these guys are my vertices. Okay, y comes first. Why does y come first? Because the hyperbola opens up and down. Now, somewhere on here is going to be my center. My center is going to be right smack dab in the middle of these two vertices, right? So let's see. What's in the middle? Well, first, I know it's going to be 2, comma. What's in the middle of 3 and negative 5? Well, middle, midpoint, average. 3 plus negative 5 is negative 2, divided by 2 is negative 1. So certainly your graph paper would tell you that. You could count on your graph paper to find out that the center is 2, negative 1. Now be really careful when you put that point into your equation, because x is 2 and y is negative 1, and they have to go, x goes with x, y goes with y. Now, if that's my center and that's my vertex, it looks like I'm going up and down 4, which means that's a 16. What else do I know? The conjugate axis is 0, negative 1, and 4, negative 1. So this is my conjugate axis. Well, if the center is 2, negative 1, I'm going back 2 and forward 2. So that means this number is a 4, and we are done with our hyperbola. So what do we have now? Now we have a couple parabolas. Well, remember, parabola equations look different. This is what a parabola equation looks like. It only has one square. And what do we know? We know the vertex is at 6, 1, so 1, 2, 3, 4, 5, 6, 1. That's my vertex. It's my vertex. And the focus, oh my goodness, is at -4, 1. So the vertex is clear out there. The focus is clear back here. This is the focus. That's the vertex. So you need to be able to tell which way this thing opens by just kind of looking at the relationship between those 2 points. This guy opens like this. He wraps around his focus. Okay, that's to the left. Well, if we're opening to the left, which letter is squared? Y. And whatever number is in this spot has to be a negative because left is a negative. Well, my vertex is 6, 1. Put the 6 with the X and the Y with the 1 with the Y. Be careful. Now, that guy right there, I have to figure out what that number is. Well, how far apart are these two? These two are, wow, it looks like they're 10 apart. If they are 10 apart, then this number has to be 40. Actually, -40. Because remember, 1/4 of that number is the distance between the focus and the directrix, or excuse me, the focus and the vertex. 1/4 of that number is the distance between the vertex and the focus. So since I know that distance is 10, that number has to be a 40. Okay, we're doing great. We're going to do another parabola. Wait, I don't know what was in there. Just have to wait a second on that. All right, let's see what we have this time. We have a focus at 1, 5. Now be careful, kids. This is the focus. This is not the vertex. That point's not going to go into the equation. That is the focus. And the directrix is x equals 3. Now somehow from that information, you need to be able to tell which way this parabola opens. Guys, I think we have another one that opens to the left. Does that make sense to you? Look at that. There's the focus, there's the directrix. I think it opens to the left. Which means, once again, we have y here, x here, and a negative. Now, that blue point right there is the vertex. And it is halfway between this focus and this directrix. Now, the focus is at 1, where x is 1. The directrix is where x is 3. So this point must be where x is 2. So that's the point 2, 5. Make sure you get the x with the x and the y with the y. Now, what number goes here? Well, that depends on what this distance is. That distance is 1. So this number must be a 4, because this distance is always 1/4 of that number. So if that's a 1, that's got to be a 4. All right. Let's see what we got now. We're ready for number 2. Question number 2. Now here we have an equation. You've done tons of these. You're good at this. We need to find the center and the radius. So let's do our grouping. Leave a blank. Now the 1's already moved over, so we're just going to leave him over there. Right here. There's the 1. And there's my 2 blanks. So let's complete the square. Half of 4 is 2, squared is 4. Half of 6 is 3, squared is 9. That is x minus 2 squared. That is y plus 3 squared. And all of this adds up to 14. So our center is at 2, negative 3, and our radius is root 14. Now, as we're going through this, anything you have a question about, you need to make a note of so that we can talk about it when I am back with you. All right, this is a handy-dandy little parabola. And we've talked about this so many times before that we're finding the vertex, focus, directrix, and focal width. That's all we're finding. And the vertex is obvious, but this one's tricky. Be careful. The vertex is negative 3, negative 1. And the focal width is 8. So we should get those right without, we don't do any work. We just look at the equation and there they are. Now, to find the focus and directrix, a sketch might help. Remember, graphs are optional. Nobody's checking it. Don't care if you do it or not, but it might help you. Which way is this thing open? Pay attention what you got going on up there. We have x being squared, and we have a positive 8. So that means this parabola is going to open up, which means my focus is going to be up here somewhere. I don't know exactly where, but I know it's straight up from that point, and I could tell you that those coordinates if I knew how far up to go. Well, how far up do I need to go? Well, look at this number right here. 1/4 of this number is always this distance. So what's 1/4 of 8? 2. So I'm going to go straight up 2, which will put me at negative 3, positive 1. That's my focus. And if I went up 2, I'm going to come down 2 to get my directrix. And my directrix then, if I come down 2, my directrix will be y equals negative 3. Straight down 2 units from this point, y equals negative 3. And that is my directrix. Okay, now it looks like we have an ellipse. Okay, we need the center and all that stuff. So let's just kind of sketch it as we go. Center's easy. You should have no problem with the center. The center is at 2, negative 1. So that's what you're going to write down in the center blank, the blank for the center. You're going to write 2, negative 1. Now I need, excuse me, I need my vertices. So in other words, I need to sketch this ellipse. So the 4 is important. The 4 tells me I'm going to go sideways 2. And this is where your graph paper can really help. Some of you like using that. You'll have a grid on your test to use. And then the 9 tells me to go up and down 3. And connect those dots. Those 4 blue points the vertices. So on the test, there's a blank that says V. Those are the vertices, and that's what goes in that blank. Yep, all four of them. All four of them. This is the major axis because it's the long one. So the major axis is how long? Let's see, I went up and down 3. So the major axis is 6. And the minor axis, let's see, I went back and forth 2. So the minor axis is 4. All right, the only thing I have left to put on there, I'm looking for another color. Hope this will show up on the video. I need my foci. Ooh, look at that orange. My foci are on the major axis. They're on the major axis. And I could tell you what they were if I knew this distance right here. Now here's my center at 2, -1. And I have to go up. How far do I have to go up? How far is it from the center to the focus point here? How far is that? The square root of 9 minus 4. Subtract the denominators. So that distance is the square root of 5. Please don't be confused by the radical. You can do this. We're clearly over 2. I'm going to start at -1 and go up root 5. And then I'll start at -1 and go down root 5. So my foci are 2, -1 plus root 5, and -1 minus root 5. And that guy's done. One problem to go on this practice test, but it's a doozy. Remember this hyperbola, there's a lot of stuff to find for the hyperbola. So let's jump in and see what we can do. Okay. I can hear your pencils moving already. Some of you are getting a head start on this. Some of you have already plotted the center. You've put oh my, I hope you've plotted it correctly. The center is at 2, -3. If you mess that up, you better fix it right now. The center is at 2, -3. Take a close look at that equation. The center is clearly at 2, -3, x comma y. The 9 tells me, because it's under y, to go up and down 3. So there's 2, 0, and there's 2, -6. Up and down 3. The 4 tells me to go sideways 2. So there's 0, -3, and 4, -3. And again, if you're using graph paper, you can count. Now let's build a box. And let's put in our asymptotes. All right, now I'm ready to draw my picture. I don't know which way to draw it, so I have to look at my equation. My equation starts with y. So I'm going to sketch my hyperbola vertically, because the y comes first in the hyperbola. So this is going to be a vertical hyperbola. That means that these points right here, right on the edge of the box where the the hyperbola just touches, those are the vertices. So your vertices are at 2, 0 and 2, -6. That means that your transverse axis, vertices is right here. I went up and down 3, so it is 6 units long. The conjugate axis, which goes the other way, I went sideways 2, so it's 4 units long. So there's your center right there, 2, -3. There are your vertices. There's your axes. Now I need my foci. Now my foci are going to be inside the curve. So I can tell they're 2, something. But I don't know what they are. I don't know what the other part of them is because I don't know how far it is from the center to that vertex. Notice from the center. I need to figure out what that distance is, and then I'll start right here at -3 and I'll go up that far. So how do I do it? Center to focus in an ellipse, or excuse me, in a hyperbola. This is hyperbola. Center to focus in a hyperbola. I add the denominators. So that one's √13. So I'm going to start right here at the center, which is -3, and I'm going to go up √13. So -3 plus √13, -3 minus √13. Those are my focus points. Now I'm almost done, guys. I'm almost done. I need my asymptotes. Asymptotes are lines. So I need a slope and a point. All right, let's talk about that for a minute. When you made this box, you counted up how many? 3. Over how many? 2. So your slope is 3/2 or -3/2. Slopes are always the same number, one positive, one negative. Now what point are we going to use? Yeah, we're going to use the center. Now kids, there are lots of points on that line. I really don't care which one you use. We've talked about this before. Just use the center. It's the easiest one. And now we have to write our equation. You can do whatever you want. I'm going to use point slope. So y plus 3 equals 3/2 x minus 2. Y plus 3 equals -3/2 x minus 2. Now clean them up a little bit. Again, you'll have a calculator if you need a calculator to help you with the arithmetic. So this one is 3/2 x minus 6, y equals. And this one is just y equals -3/2 x. There we go. Those are the equations of our asymptotes. And that problem is done. And so is practice test number 2. So now we're going to do number 3, which is formatted a little differently, but number 3 is actually the length of the test. Notice that there are 8 questions. It's exactly the way the test is. Now, the test is spread out, but to save paper, I just did this on one page. But But here we go. Let's see if we can get through these 8 problems, and then we'll be good to go for our test. Remember, if I'm going too fast or erasing too much, just back me up, put me on pause. Here we go. Number 1. Now remember, this is formatted, practice test number 3 has exactly the same number of questions as the test does. So we're going to write the equation of the circle whose diameter has endpoints at -2, 4, and 6, 10. Okay? So we need to find the center and the radius. In order to write the equation of this circle, we're going to need the center and the radius. So, how do we find our center? Well, we average the x values and the y values. So, -2 plus 6 is 4, divided by 2 is 2. That's my average x. 4 plus 10 is 14, divided by 2 is 7. So the center of my circle is at 2, 7. So x minus 2 squared plus y minus 7 squared equals something. Now, in order to figure out the something, I need to figure out my radius. So what is my radius? Well, I'm going to do my distance formula. So my radius will be the distance from here to here, or from here to here, whichever one you want to do. So I'm going to do 6 minus 2, subtract my x's, 10 minus 7, subtract my y's. So that gives me 6 minus 2 is 4, squared is 16. 10 minus 7 is 3, squared is 9. So that's the square root of 25, which is 5. So my radius is 5, which means this number is 25. Remember, that's r squared. Okay, that wasn't so bad. Now number 2, I have an ellipse. Here we go. This is an ellipse. What do I know about it? All I know is the major is at 2, 9 and 2, -3. That's the major axis right there. And the minor axis is 0, 3 and 4, 3. Right there. So here's my ellipse, and right there's my center. What point is that? Look at what you have going on there. That is the point 2, 3. So x minus 2, y minus 3. Now I need the numbers underneath. Well, let's see. In the x direction, looks like I counted back and forth 2, so the x gets a 4. In the y direction, it looks like I counted up and down 6, so this guy gets a 36. There's your ellipse. Now we have a hyperbola. Notice that these two equations look the same, except the ellipse has a plus and the hyperbola has a minus. Now what do I know about my hyperbola? This is question number 3. The center is at -1, 2. That's the center right there. And it opens vertically. Now, gang, I don't know where those vertices are, and I'll figure that out in a minute. No one's grading your picture. Don't get hung up on it. What's important is we're opening vertically. That means that y comes first in my equation. That means that I'll have y minus 2 and x plus 1 in my equation. Now it says the transverse axis, that would be this one right here. The transverse axis is 16 units long. So that means I'm going up and down 8, which means this gets a 64. If it's 16 units long, you're going up and down 8. So that's a 64. The conjugate axis is 18 units long, which means you're going back and forth 9, which means that guy gets an 81. And that problem is done. Now we're going to do a parabola. This is our last equation we have to write. Looks like this. 1 squared parentheses. We know the focus is at negative 3, 7. Now keep in mind that is the focus. Don't put 3 and 7 in these parentheses. That's the focus. And the directrix is x equals 5. Well, I can't believe it. This seems like the third one in a row, if my memory is right. But I think this guy's opening to the left. I'll do it in my orange marker. This guy is opening to the left. And I don't know where that vertex is exactly, but it's halfway between negative 3 and x equals 5. Yeah. Now, if we're opening to the left, then y is squared, and we have a negative coefficient. I really need my vertex. This is my vertex, this big bright orange point here. I really need to know what it is. I can tell it's up 7, because it's right in line with that one. And it's going to be halfway between negative 3 and 5. Now, if you don't know what's halfway between negative 3 and 5, think of the midpoint, think of the average. Negative 3 plus 5 is 2, divided by 2 is 1. So that is the point 1, 7. If that doesn't make sense to you on your graph paper, just count. So y minus 7, x minus 1. That is my vertex. Now I'm all done except for that coefficient. How far is it from here to here? What's that distance right there? That distance is 4. What does that mean about that number right there? It's got to be a 16. Why does that number have to be a 16? Because a fourth of that number is the distance from here to here every time. So if this distance is 4, then this has to be a 16. All right, so this test is half done. Now we got to do the other half, and the other half, we've already practiced it today, but this is where we find the information. So for number 5, it's a circle, and we're going to find the center and the radius. I have a feeling you guys can do this with your eyes closed. We've done so many of these. So we'll group our x's. We'll group our y's. We're going to move that 4 to the other side. Here we go. Half of 8 squared. Half of 2 squared. Watch that one. For some reason, we miss that one sometimes. Half of 2 is 1, and 1 squared is 1. So we've got x minus 4 squared, y plus 1 squared, and over here, what do we have? It looks like we have, what is that, 13? So where's my center? 4 comma negative 1. And what's my radius? Square root of 13. Oh boy. Now we have the doozy. Now we have our hyperbola. If you're not sure when you look at it that it's a hyperbola, look at the question. The question says, what are the asymptotes? Obviously, it's a hyperbola if it has asymptotes. None of the rest of our things have asymptotes. So we got a lot of stuff to find. Here we go. Let's do a little sketch. Our center, we got that right off the bat. We know our center is at negative 3, negative 5. Okay, so even if you know nothing, you can get that one right. That's our center. Now the 16 tells me to count back and forth 4. So 1, 2, 3, 4. And 1, 2, 3, 4. Now I'm labeling these right now. You don't necessarily have to do that because you don't have to be drawing it at all. But I'm just labeling them so I have them labeled. Then I'm going to go up and down 5. And I'm going to build a box through those points. There it is. And I'm going to go ahead and draw in my asymptotes. Don't worry, they don't have to be dashed lines. I'm getting kind of tired, so I just made them solid lines this time. I got to draw my curve. See this guy right here? That tells me we're opening sideways. So this hyperbola opens sideways. And these blue dots right here on the edge of the box, those are your vertices. So in the blank that says vertices, 1, negative 5, negative 7, negative 5, those are your vertices. This is your conjugate axis then. These blue points are your vertices. There's 2 of them. These blue points right here, those are your vertices. These are not vertices. Don't put those down. Only the blue dots are vertices. How long is your transverse axis? Your transverse axis is 8 because you went 4 and 4. The conjugate axis is 10 because you went 5 and 5, up 5 and down 5. The foci, these green points right here, these are your foci. I don't know where they are, but I can figure it out. If I know this distance right here, I'm going to start at the center. Always start at the center and come forward and backward however much. How much? Well, the center to the focus in a hyperbola is the square root of 16 plus 25 or root 41. So So I'm going to start right here at -3, and I'm going to add root 41 and -3 minus root 41. Now remember, the foci are points, so you have to have an x comma y. Your x is the -3 plus the root 41, but your y is still -5. They're all in that -5 line. Now I need my asymptotes. I need a point and a slope. All right, here we go. The point we're going to use, -3, -5. The slope I'm going to use, start right here. I counted up how many? 5. Over how many? 4. So my slope is 5/4 or -5/4. Now I keep saying this. We're old enough now, we need to be able to write equations of lines. If the fractions bother you, then use your calculator. But you got to come up with the equation of the line. Using either point slope or slope intercept form, I don't care. I'm going to do point slope, y plus 5 equals 5/4 x plus 3. Y plus 5 equals -5/4 x plus 3. So y plus 5 equals 5/4 x plus 15/4. Y equals 5/4 x minus 5/4. Now again, you're using your calculator or you're working off to the side. I'm subtracting 5 from both sides. That's 20/4. So when I subtract 20/4, I get -5/4. Same thing over here. Only this time I'm going to have -5/4 x minus 35/4. Okay, there they are. There are our asymptotes and everything else for the hyperbola in number 6. All right, 2 more questions, guys. Hang on. Then you will have done the whole test almost twice. So number 7, what do we have there? A parabola. So this is a parabola. Some of us need every point we can get, for Pete's sake. We keep talking about this. You can get half of the points for this problem without knowing anything. Where's the vertex? Watch it. -1, 4. -1, 4. And what's the focal width? 16. Please don't put the negative in there. The width of the parabola is 16. All right, let's see what it looks like, because that's going to help us find our focus and directrix. So we're at -1, 4. That's my vertex. And which way am I opening? This is critical. Which way is this guy opening? Pay attention. Oh my gosh. It's a y² negative. I think it's going to the left. I feel like every parabola I've done has been to the left. This one's to the left. It's a y² negative. That means that my focus is right in here. I could tell you what that is if I knew that distance right there. I do know that distance because it's 1/4 of 16. 1/4 of 16 is 4. So I'm going to start right here, and I'm going to back up 4. Well, where am I going to be if I back up 4? -5, 4. That is my focus. Now, if I backed up 4 for my focus, I'm going to go forward 4 for my directrix. Well, if I start here and go forward 4, I'd be at x equals 3. That's my directrix, x equals 3. Remember, in a parabola, to get your focus and directrix, you go 1/4 of that number. Always 1/4 of that number. Last problem, got little ellipse here. Okay, here we go. Where's our center? Easy peasy, -2, -5. I'm going to redraw this because this is going to get, I'm going to go off my blackboard. So -2, -5 is my center. What does the 16 tell me to do? The 16 tells me to go sideways 4. So if I go sideways 4, I've got a point at 2, -5, and a point at -6, -5. And then I'm going to go up and down 5. So that's going to put me at -2, 0, and -2, -10. Those 4 points are my vertices. So when it says find V, that's vertices. These orange points, all 4 of them, are the vertices. Okay, this is my longest axis. I went up and down 5, so my major axis is 10. And I went back and forth 4, so my minor axis is 8. Hang on. All we have to do is find our foci and you are done. Foci are always on the major axis, so they're here. They're up and down. How far up and down are they? Well, I don't know. I need to figure that distance out right there. How far up do I go from my center? Well, in an ellipse, we find the distance from the center to the focus by subtracting. So 25 minus 16 is 9, and the square root of 9 is 3. So I'm going to start here. Now, by the way, that's a nice number. No more radicals. I'm going to start here and go up 3. So that would put me at -2, -2. And if I go down 3, that puts me at -2, -8. So those blue points are your foci. And that, my friends, is it. That's your test. Those 8 questions. Practice, practice, practice. Have a great day.